questions on Moodle was like referring to the problem before it, but it didn't line up with that problem before it.
Okay, could you send me an email on which exact problem, and then I'll fix that and make sure nobody is.
I had it too. But it was an outlier question, and it was kind of like the answer was fairly obvious because there was like a number that was really large. So you're like, okay, it's probably that one.
Right. Okay, so yeah, I'll fix that. Everybody's doing okay? If you see any questions in Moodle that seems like there is an obvious typo, please send me an email so that I can fix it. And you're not penalized for that as well. Any questions from last time? All right, so last time we ended at the definition of the sample variance. So if I have n observations, x1, x2, xn, then the sample variance, which is denoted by s squared, is given by 1 over n minus 1 times the summation I going from 1 up to n, xi minus xi bar whole squared. Remember, x bar is the sample mean. It is important that all right, I'm not going to say it, I'll just restart my OneNote again. Okay, so one thing that I want you to realize, so that summation that I have, make sure, or what is the, write it out in expanded form. So that sum that we have here is, so the summation I going from 1 up to n of xi minus xi bar squared, so that summation is what? It is x1 minus x bar squared plus x2 minus x bar squared plus dot 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 plus xn minus x bar squared. Okay. Is everybody okay with that? Now, in the sample variance, the sum and xi minus x bar squared, that's called the squared deviation of xi from the sample mean x bar. df here denotes the degrees of freedom, and the degrees of freedom here is n minus 1, and that's what you see. The n minus 1 you see in the formula for the variance is the degrees of freedom. And I also last time noted that the sample variance can be written in a different form, which is the summation of xi squared minus the summation of xi whole squared divided by n, and then the whole thing divided by n minus 1. Okay, so this is just you can derive number 3 from the definition of sample variance just by doing some algebra. Okay, I won't go through that. So The reason I'm also giving you number 3 here is because a lot of the times it is easy to work with than the other one. Okay. Now number 4. For observations y1 through yk with frequencies f1 through fk, the sample variance will be given by the summation xi squared times fi minus the summation xi fi whole squared divided by n, and then the whole thing divided by n minus 1. Okay, so this is the formula that you would want to use in case you are given the observations with frequencies. So y1 has frequency f1, means that y1 repeats f1 times in the data, right? And in that case, n is the total frequency. N is the total number of observations, which is the same as f1 plus f2 plus data dot plus fk. Is everybody here? The formula number 3 and 4, they are exactly the same. Formula number 3 and 4, they are exactly the same. The only difference is, you're multiplying by fi. Now, if you're not multiplying by fi, then you have to repeat xi squared fi times in the sum, right? Everybody gets the formulas? Okay. I'm going to show you an example in a bit. Let's look at now, variance, remember, is a measure of dispersion, right? So if you look at the formula for the variance, right? If you look at the formula for the variance, the first formula that I gave you. So look at this formula for variance right here. If you think about it, you are taking the formula for the variance is giving you average of the squared deviations of the observations from the mean, right? It's the average of the squared deviations of the observations from the sample mean. That's a long sentence, I hope that made sense. So that means this is a measure. It's giving you a measure of how the observations are clustered around the mean, right? It's telling you how the observations are clustered around the mean. Okay. Now, one problem with the sample mean, though, is that it's giving you squared deviations, right? You're looking at squared deviations. So let's say that the unit of the observations is, let's say, inches. The unit for the observations, let's say, inches. Well, in that case, what is the unit for the sample variance? If the unit for the observations is inch, right? What would be the unit for the sample variance? Yeah, squared inches, right? Well, so that means the unit for the observations doesn't match the unit for the measure of dispersion, right? And we would like a measure that has the same unit. We would like a measure of dispersion that has the same unit as the observations. And for that, we have standard deviation, which is basically standard deviation. Sample standard deviation will be denoted by just S, and it is just the square root of the variance. remember we used s squared as the notation for the variance, right? So you take the square root of that, and that's the sample variance. Okay, now standard deviation has the same unit as the observations, right? Standard deviation has the same unit as the observations. Is everybody clear? Well, let's look at an example. In my example, I'm going to use the first formula of variance that I gave you. Okay. So, in my table here, I have some observations, and I guess how many observations do I have? Are you guys done writing down this first line? Okay, so let me move up a little. Okay, here's the table, and so I have 14 values here. The first column is basically telling me how many values I have, and the actual observations are in the second column. So I have 14 observations here, and the observations are in the second column, so it's 59, 60, 61, 62, 62, 63, 63, 63, 64, 64, 65, 66, 67, 68, right? Once I have the observations, right, I can find the sample mean. What's the sample mean? The sum of the observations divided by the total number of observations, right? So the sample mean here is going to be 63.4. Is everybody okay with that? Okay, so sample mean is 63.4. Now what I did is in the third column, each entry is the x bar. Every entry in the third column is x bar. Okay. Now the fourth column, what I did is I calculated the deviation of each observation from the mean. Okay. So if you look at the first observation 59, what's the deviation of that from the mean? Well, you subtract the mean from that observation, what do you get? What is 59 minus 63.4? So that's negative 4.4, right? What is 60 minus 63.4? Well, that's negative 3.4, right? And so on. Let me give you another example. What is 65 minus 63.4? Right, that's 1.6. Is everybody okay? All right, so once I have the deviations, then I calculate the squared deviations. So then the last column here is the square of the fourth column, basically. So you take the square of each deviation, and that's what we have in the fourth column. So then you take the sum of the squared deviations. You take the sum of the squared deviations, and it turns out to be 85.2. Okay? So what's the degrees of freedom here? What's the degrees of freedom here? The degrees of freedom here is 1 less than the data size, right? And 1 less than data size here is 14, so 1 less than that is 13. So the degrees of freedom is 13 here. Sum of the squared deviations from the mean is 85.2. So what's the sample variance? The sample variance would be the sum of the squared deviations divided by the degrees of freedom, 13, which would be 6.55 inches squared. The observations that I have here, these are heights of certain women in inches. Okay, so because of that, the unit for the variance would be squared inches, And then once you have the variance, you can calculate the standard deviation. Standard deviation would be the square root of 6.55, which is 2.56 inches. Once again, the unit for standard deviation is the same as that of the observations, right? So it will be inches. So in this table, the observations that I have, they are in inches. Any questions on how we can calculate the sample variance and sample standard deviation? Anybody have any questions? Once again, I want to remind you that I have posted instructions on how to use TI-84 to calculate sample variance. You should look that up. Make sure you know how to use that. If you are not sure how to do that from reading those posts, you can come by my office. I can show you how to use it. But I'm pretty sure most of you are tacky enough to be able to follow those instructions. What's that? All right, so any questions on this anymore? No? All right, so let's move on to another example. So in this example, what I'm doing is I'm giving you an example of how to use the formula for variance that I have given you in number 4. So remember, this is the case where you are given observations with frequencies, right? And that's when you're going to use this. So let me show you that example. So in my table, the first column gives you the distinct observations: 225, 265, 305, 345, 385. Second column gives you the frequencies of these observations. So the frequency of 225 is 3, the frequency of 265 is 11, and so on here. So what does that mean? It means that 225 repeats 3 times, right? Or 225 appears in the data 3 times. So those are the frequencies. Now, if you look into the formula, you will see that in the numerator, the first term is the sum of the product of xi and fi, right? Sum of the products of xi, fi, right? So what I'm going to do then is calculate xi times fi. So each observation will be multiplied by its frequency. So that's the third column. Third column is obtained by multiplying each observation with its frequency. Okay, so once I have that, the last column is you take the square of each observation and multiply that by its frequency. So it is xi squared times fi. Is everybody okay with that? Now, if I wanted to, I could have made another column with this squares all the observations, right? If I wanted to. And then I could have multiplied that column with the frequency. So, I mean, if you know how to use Excel, you know, it might be useful to do that. Right? In Excel, you can write a one-line command where you say, you know, multiply, you know, the A1 entry with, you know, B1 entry, right? And so on. If you don't know how to use Excel, that's fine, and we don't have the time. I don't have the time to show you how to use Excel. Maybe in future, if I see that I can use one class hour, I'll do that. But you can use TI-84 to do this. Okay, so what's the variance? So the variance is given by the summation. It's given by the summation I going from 1. How many distinct observations do we have here? 5 of them, right? So I is going from 1 through 5, xi squared times fi minus summation I going from 1 up to 5, xi times fi whole square divided by n minus 1. Now n here is what? N is the total number of observations. That's the same as total frequency, and the total frequency here is 50. Now you take the sum of xi fi, you get 15,250, and then you take the sum of xi squared times fi, and this is what you get. Okay. So. So what is that? 4,728,050. Okay, so you plug them in, and you calculate, and what you get is 1567.35. Now, this is the variance, so if you need to find the standard deviation, all you have to do is take the square root of the variance. So the standard deviation S will be the root of 1567.35. Now, when you have small data set in the homework, try to do at least one example by hand so that you remember the process. And then you can use TI-84 to find the variance for you. Okay? But it's important to understand what the variance is measuring, okay? And, you know, what the median and the mean they are measuring as well. Okay? So this is the end. This is the end of the discussion on variance. Okay, and we are going to move into chapter 3 now.